go through web only. Very good morning, very good afternoon, everyone. Very good afternoon. I'm Dr. Umari Sharma, and I'm working as an academic consultant at CIT Ncert. And soon we will going to start a very interesting content in visual learning, which is here we explore two tools which are very, very useful, especially in the case of physics and engineering. Right. So we will soon start it. And the topic is visual learning, that is exploring Falstad applets and algorithm. Both are very interesting. So when we do it, I want everyone to engage with it, and they will do the hands-on learning at the same time. So I will wait for 2-3 minutes more, because only right now 18 are there. Maybe more physics resource persons are there. Physics participants are there. So they are soon joining. Okay. So meanwhile, what you can do, you can simply go through algorithm, and you can type algorithm in a Google's. Simply you can type it algorithm, and you can download a window version. You can download a window version for the same. So this can help the time when we are we can do more examples rather than simply downloading process. If you are working in the laptop, please join with laptop. It will be more convenient to you. Yes, D. Ramakrishna sir. You can join through laptop only. For mathematics, okay, there is a separate link. So, number of participants are increasing. I hope everyone is sitting with their laptops. Okay, I can. I think I should start. It's nearly 4 o'clock. I think I should start. Is it okay if I start it now? Everyone is ready? Kindly be interactive.
Yes, ma'am.
Okay, okay. So we will start it. So first of all, we should know what is a visual learning, first of all, and why we are in physics case, how it is helpful. So basically, we know that this visual aids enhances learning in maths, physics, and engineering by simply transforming abstract concept. You know about the waves concept is there in physics. You know about diffraction, reflection, sound waves, how sound wave travels. Okay, so these are a very abstract concept. And to understand this abstract concept, it should be some visual tools are really necessary for proper understanding, especially in grade 6, 7th, 8th, when it is we are building the concept to the students, right? So it will be really very helpful for them. That's why here we are coming with 2 tools for visual learning. Especially here we are considering simulations are there, interactive diagrams are there, which we are making a complex theorems and complex laws which are available, which are there, like Newton's third law is there, Newton's second law. Simply rote memorization of statement is not recommended as per NEP 2020 also. We cannot simply tell them to just remember it. Okay, just remember all the laws without any understanding their applicability. Yes, yes, Urmila ma'am. Yes, Urmila ma'am. Good afternoon, ma'am. Yes, Kesh Das. Yes,
video link for downloading.
Madam, your audio is not clear.
audio is not clear.
Already shared, and I've
Yes, ma'am.
shared this presentation also, so that you can download it during the session, and you can also practice with me. So it will
Sorry.
you will just see the content through this presentation and all. It will not be fruitful. I want all of you to work.
Sorry, ma'am, your audio is not like I'm unable to understand what you are saying. Yes, I'm sharing the hands-on learning. It's not simply presentation.
At one place, then we'll start with the leave in between. That we are getting bored and we will not study that thing.
I understand, ma'am, your point. So it's not a PPT, it's a hands-on learning session, especially for tools only. Hello. Hello, ma'am. Am I audible?
Yes, ma'am, you are audible.
Yes, ma'am, you are audible. Perfectly. Okay, ma'am.
You are
Okay,
Your sound,
okay,
this voice is audible.
Okay. Just give me 1 second. Okay, so we are going to start it. So simply, this is everything you know about, because being a teacher, you know how to bridge the gaps, how the students struggle, what do you mean by the interactive learning. So better not to waste time in it. We will simply go to the tool. Okay, so this is the first tool which we are doing right now. This is a Falstad applet.
Madam,
Yes. Hello.
Madam.
Yes, sir.
Hi.
Hello, sir. Hello, sir.
I just joined, madam.
Okay, you just joined. So, sir, basically, this is a subject I am just sharing the subject-specific tool for physics, and which is Falstad. This is a Falstad applet, which is basically applets which are written in the Java language, and which is free software. Anyone can use it by simply which they are having a simple internet connection. With internet connection, they can simply get it. No need to download anything, nothing else. You simply go to the falstad.com. I will tell you how to do it. Just have an intro of this tool, and then we will move ahead. Is that clear, sir? Kindly, I will appreciate if everyone come to the video mode, so it will be more interactive.
Okay, madam.
It will be more interactive, and to me also, and you will also enjoy the session. Okay, sir. Okay, so what is the key feature of this? It is a simply, what I will tell you, it is a simply collection of educational applets are there, where we can visualize the various concepts, both in mathematics, in physics, in engineering. So especially for like in 10th grade, we start tell them about current electricity, even in grade 6th also, simple what are the electrical components are there. So how they can visualize it. Either we go to the lab or some other places to just show them how the circuit operates. Then there is several misconceptions out there, okay, about the current electricity. So this is a platform where the student can learn all these things very interactively. Okay, so let's start it. Here the key feature is this only. It has no downloads. It is a simple browser-based tool is there. So let's start with what you have to do. All of you kindly go to the www.falstad.com. Yes, www.falstad.com. Okay. So once you go over there, simply by Google Falstad, this kind of screen is appear. in your Google Chrome. Is it so? Yes.
Yes, ma'am.
Okay. So here different, you just click on the circuit simulator applet first part only. So you will get a simply this kind of a picture. Isn't it? So I will directly go to the, in spite of this PPT, I will directly share you, go to the link itself. Okay, so that will be more and put hands on them.
Madam, your audio is very low.
Audio is low. Now, sir,
It's audible, but
it's audible.
It's audible, ma'am.
Audible, but audio is very low.
Just give me a second. I'm sharing the screen. I'm sharing the screen. Just wait a second. Just give me a second. Just give me a second. Yes. Now, is it visible? Hello?
Yes, visible, ma'am.
Yes, visible, ma'am.
So as
I'm
soon as you
audible.
open it, you will get this kind of picture, isn't it? This is a basic LCR circuit, sir. Basic LCR circuit. And this is a tool where this is a wire is there, this resistor is there, ground is there, and you can see inductor is there, NOT gate is there. Okay, this battery is there. So all the electrical component are available over here. And this is this is the first, by default, this LCR circuit will come. And if you observe this, here you can control this simulation speed also. You can control the speed also. This yellow dot is the current flowing. So you can control this speed also. And here, because here we have considered three components. Capacitance is there, inductance is there, resistance is there. So you can increase the capacitance, increase or decrease from here also. Inductance is there, resistance is there. So how the current varies when we changes the different electrical component. So this is a platform where the student can learn about this in the graphical format also. You can see here three oscilloscopes are there. One is for inductor, one is for capacitor, and one is for resistor. As you put a cursor over here, you will observe, you will see what is the value is going on. You can stop it also, and you can observe. See, in resistor, we know that voltage and this current both are in phase. So you can see that both are moving in phase. In class 12th, this is a AC, like one chapter is there, alternating current. And there you can see that how they understand the behavior of this resistor, how the current flows over there, how the AC current flows over there. Here it is a DC only. And here you can see in the case of capacitor, you can see in the case of inductor, how there's a lagging is there. And in the case inductor, how it is leading. So in this, or there is a one more option is there in scopes. We can combine all the scopes all together to see how how the behavior of three components, how the voltage is varying, And in the left side, you will observe this for the case of inductor. What is the value of current? What is the value of this voltage? Inductor value? What is the power? So this is the great one. Now, apart from that, there is a certain circuits, inbuilt circuits are available. You can see inbuilt circuits are there. Basic circuit, Ohm's law, resistor, capacitor, inductor, LRC circuit. This is the LRC circuit only. So let's go to the Ohm's law. So this is a basic Ohm's law structure is here. How the voltage, how V is directly proportional to the current. V is directly proportional to the current. Simply you can change the current, and if you see it over here, the current will change. Next, diodes are there. You can create this is a diode. Now you can create your own also. Like you can see it over here. You can go to the new blank circuit. You can go to the new blank circuit here. Okay, there are different tools are there. File, edit, draw, scopes, option, circuit. So one very small example I will show it over here. How to draw a simple circuit. Okay, so just make it blank first of all. Take this wire, just connect it. Then take a resistance like this. I will make a simple circuit, simple in series circuit. Resistance which are connected in series. And let's say, yes, Vishal sir, I will come to you. I will come to you. You have raised your hands. I will come to you. Then battery. Just connect it with battery. Or we can go with this keys also. This two-way keys is also available over there. I can connect this key also. Now, once this is complete, circuit is complete, you can see the current is flowing. That means our circuit is okay. Here it will give you one more advantage. If I connected some wrong connection, suppose I will just draw one more connection over here. Here it shows one bad connection. So instantly you know that I have connected it wrongly. So you can simply cut it. Simple control X, it will be deleted, or simple control X for cutting, control V for pasting, or control C for copy, and control V for pasting. So this is a very simple thing. I will come to chat. There is some questions. I got it. Achha. Now I think my audio is okay. I will try to go slow. Screen is not shared. Screen is shared, na sir?
It is shared, ma'am.
Okay,
Yes,
okay.
ma'am, your
So this
screen is visible.
Okay, so very simple circuit. I have connected 4 resistors in series. Now we can explain student in this form also how if we connect a battery in parallelly. Okay, when we connect battery in parallel, then what happens? What is the behavior of these voltages or in the combination of these voltages? Similarly, I can show for the parallel connection also. I will draw one parallel connection. One parallel connection, and at the same time I can change the value. By default it is taking 1K. I can change this value also. Simply you can right click on it. After right clicking, you just go to the edit part and edit. You can edit you can make it 10 ohms, 20 ohms, 30 ohms, whatever value. Okay, 30 ohms I have taken. Here I can edit it in the similar way. I can edit it. I can take it to 10 ohms. 10 ohms, okay. And let's take it this one as a 20. Edit. 20. Okay. Now these 3 resistors are in parallel. I have connected. Then with the wire, I will just join them. Again with one wire, I will join them. Then I want to join it with the battery. So again, I need a wire. So I can go it like this, like this, like this. Now this. Okay. Now you can join this key also. I will join one key also. And then I will connect it with the battery. Okay, I want to connect battery. This is one cell only. I will join 1, 2, 3, 4, and I will join this. So as I joined it, so as I joined it, the circuit is closed. Now, sir, I have opened it. Circuit is open. This is little bit looking clumsy. I will delete it. I will join with wire. I will join these 2 back with wire. Now it's okay. Now as it closed, switch is closed, open, switch is open. So this is a very good platform to show the parallel connection to the student. Plus we can join bulb also. Like in place of this thing, I will delete this part and I will add this bulb output. So for that, we can go for draw option. There are add register, passive components are there, input and sources are there. This is for especially if you want to add ground, add voltage source, AC terminal, voltage source, one terminal, clock, especially if we draw the, in the case of electronic circuits, D flip-flop, JK flip-flop, for that thing, we require this clock thing. And you can, we want output. I want to add bulb, so you can add LED or add lamp. I will take lamp. So I will join it with this over here, lamp. Now you can see this as I close it, it will shows that it is easily passing through. And I can go through this current also. I can change the speed of this current also. Okay, so this is the one thing. Now, one thing, how to, one more thing, one more example I will show by new blank circuit for specially explaining Kirchhoff law, suppose Wheatstone bridge thing. Okay, I want to explain them about the Wheatstone principle. I hope everyone knows about the Wheatstone principle because being a physics teacher, we are teaching them in their classes also. So simply, I just draw the Kirchhoff Wheatstone bridge structure. And I want to show that how the bridge is balanced. Okay. So again, with the same wire, you can take this wire, you can join it like this. And I will take one battery. You can also do this at the same time. See? And now I want to, one galvanometer is there. So from the scope, from the option, draw option, input, not input, I want voltage. Voltmeter, add voltmeter. Okay, add ammeter is there, voltmeter is there, ohmmeter is there. I want voltmeter to check the potential difference between these two. Now you can see this as all the four resistors are equal. So it's showing the potential difference 0. Now if I change, suppose if I change one of the resistors, edit, I will make it suppose 2K. In that case, there is a potential difference. So we can easily explain about this potential difference thing about how the bridge is balanced, Wheatstone principle, P by Q equal to R by S. Now, how to download it? Yes, in FATE also, can we make? I have not tried. Maybe it is available, but circuit simulation I have not seen. For circuit, it is the best platform which I have seen because it is here the standalone version is easily available. Now, how to download it? It is like if I draw the basic, this is a customized one. If there are different inbuilt circuits are available here, you can see basic are there, AC circuits are there. There are inbuilt circuits are available there whose standalone version are easily downloadable. But for this, suppose I want to download it, simply you will go to the file part. Okay, you can go to the file part and you export as a text. Okay, first of all, export as a text. You will see this kind of text is available. Okay, now you can save this kind of text in a notepad. आप इसको notepad में you can just simply save this thing in the notepad on the desktop. Once it is saved, okay, once it is saved, copy to the clipboard. Okay, once it is saved, control C, suppose. Okay, now I have at the school, I want to show this diagram which I have made at the home. Okay, to just showcase the student how to make, how to just explain it to save the time. I simply want to explain all this. Okay, I don't want to draw it again. Simply, it is already saved in a desktop, in a notepad form, in a text form. So you just copy that text from the your desktop and simply go to the file, blank circuit, blank part, and this import from the text. Here you click on the import from the text. As you import from the text, I have copied that text over here You just control V and OK. It's comes. So whatever circuit at your free time, at the home you have waited to explain students about the series circuit, parallel circuit, Wheatstone bridge, whatever concept we are teaching at school level. So we can save it in the document form, simply in the document or in the notepad. And at school, you can simply go to, it is a web browser only, in the Google itself. You don't have to download again and again any software. Simply go over there and click on this. In this way, you can import that file, and that configuration of the circuit is available. Is it clear? Is it clear?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. It is clear, ma'am.
Okay.
I mean,
Understood.
FET also we can do this thing now.
Circuit simulation, ma'am, I have seen different like conservation of energy is there, different concept, buoyancy is there, different concept we can understand by FET. But for this circuit simulation thing, how to make the circuit, that thing I have not
Hello?
seen right now. FET.
Ma'am.
If you have knowledge, I will check it once and then I will let you know. Yes.
Hello?
Yes, sir. Yes, sir.
Actually, just I raised the hand for one purpose only. Like I'm like failed to find out where is that path difference. Like the current and voltage it is showing, but in previous figure, no, the which you shown LCR circuit. So the phase difference, like I couldn't find it actually. If you could help me out in that case, then.
You just go to the scope part. But here, see, it is a simple DC circuit is there. So no, everything is going in same phase only.
Right.
Current and voltage. So here you will not see, it is not available here. But if I go to the option or go to circuit, suppose any AC circuit, I will take it, capacitor. Here you will see. Okay, sir.
Right, ma'am.
So in the capacitor circuit, you can see that it is acting like a just oscillator like thing, because once it is in a positive cycle, it is charging and then it comes discharging in this way.
What I'm asking, ma'am, the readings are there, no, right? Like current
Yes,
is there,
yes.
voltage is there, capacitance is there, even power is also there. But what I mean to say, where it the like that logo shows the phase difference between these two waves. For example, there are two waves, no, one is current and one is voltage. So right now there is 90 phase difference seen.
Yes, 90 phase difference is there. Yes.
But where we can like show to the cadets or students there is a 90 phase difference on screen here, because we can understand.
No, but it is a phase difference. We know theoretically that there is a 90-degree phase difference is there. So, so theoretically, like we cannot change that phase part over.
What I did, ma'am, if you change the speed of the current or capacitance value, the phase difference will also change, ma'am.
Yes, it changes. No, phase difference, how it will change? No, phase difference will not change.
No, phase difference will not change if
Phase
the
difference will not
amplitude
change.
and currents are changing.
Phase difference will not
Phase
change.
difference will remain
It
same.
remains 90 only. It remains 90
Yes,
only.
ma'am.
Phase difference will not change. You can change this thing, but see, as the current changes, capacitance will also changes. Their intensity, see here you can see their intensity is changing.
Right,
okay?
amplitude.
Their amplitude is changing, but not their phase difference. Phase difference remains at 90 only. And the capacitance in this case, it is a leading, current is leading potential by 90
Current
degrees.
leads by 90 degrees.
Yes, absolutely. Okay, so we will go to like some very, like if you are, I will show you this thing also, half wave rectifier. This is also very important concept which we explain in the grade 12, how half wave rectifier is going. See, this is the input, 5 volt input, AC source, there 40 hertz is there, and at the output, we are getting, see, how we are getting the output only half. Okay. Similarly, you can make it create by your own also. You can directly take the template. I will go to this AC circuit again from where I have seen other passive circuits. Diodes. In the case of diodes, whatever circuits are made from the diodes, they are here. Okay. It is very much interesting for electrical engineering students. Suppose the JK flip flop, very nicely you can create JK flip flop, they can see the output. Okay, now full wave rectifier. This is a different kind they have made, but the thing is same, two diodes we have used. two diodes we have used. This is different configuration. I think is it bridge one? Different configuration they are used, but its output is this only repulse form full wave rectifier. You can see this voltages. Okay, so they can make it their own also. Now, other one more part I want to show you. Suppose logic gates. Okay, draw logic gates. So I will add. Suppose add D flip flop.
D flip flop.
Here only. D flip flop. This D output is available at the same time. The separate output will be there. You can make it this NOT gate is there. NOT gate is there. AND gate is there. Sorry, this is the diode is there. This is NOT gate is there. Here different form of gates are there. This is AND gate, NAND gate, OR gate, NOR gate, and XOR gate. All the gates are available. So if you want to showcase this also, so here inputs, its inputs are also available. Here you have to select the appropriate input active components. Like here, this is the output and labels. For all the inputs, you have to go inputs and source. For the input and source, you have to check, see which kind of input you want over here. It's a two-terminal, but voltage data. For this, it is a data. I have one logic gates, input and output. You have to go over here, logic gates, input and output. Okay, and add logic input. I have to do it separately, I think. So V out 5 volt, I out 0 ampere, because right now it is not connected properly. So it should. So there are plenty of things are available in this settings. Now let me come back to the PPT. Is it visible? My PPT is visible?
No, ma'am.
Screen is visible, ma'am.
Screen is visible, but PPT. I want to give you one assignment. Now it is visible.
No, ma'am, it's not visible.
The screen is visible. The PPT is not
No,
visible.
PPT is not visible. Yes, ma'am.
Yes. Now
It's visible now.
Okay. Now I want to show you one. This is a small one video I have how to download it. Just give me a second. Huh? Is it visible? Please don't leave that now. Otherwise, the time is all and will be grateful. Is it visible?
Yes,
ma'am,
ma'am, it is.
visible.
So this is a small video I have made how to save it, circuit, the standalone version of it. The one method I have shown you, that's a very simple one, which I have derived from it while doing again and again. Very simple one to just save the text format. And this is another one, which is like the whatever circuits which are inbuilt over here, which you can simple go to the download version, standalone version of it, and it downloads the entire files for it, and then we can extract all the file from it. This is like, suppose you want to take like in a bulk, you want to show all the components, because here simulation is also attached with it. Okay, you don't have to like open again and again the entire website. Here directly, this is another method by which you can save the entire standalone version of whatever circuit you have. You can see the circuit JS is there now, and this circuit JS. When you open this circuit JS, the circuit which I am sharing you before is now available. You can see it over here. It is a little bit slow. And Now it is available. Now here, so wherever any desktop, in any suppose internet is not available at that time. So without internet, this is, you can easily access this thing because all the file is available right now. With all the simulation and everything, this is there. So this is helpful in the case when internet is not available. Is that clear? And again continue to geography, and from there I am again continue to biology. Any query, sir? This is another method which I have explained to you already, how to save the file. Okay. Copy it, save it in the notepad, and in another desktop or another any other place you want to open it, simply copy that notepad, copy that text from the notepad. The same circuit will come over. I hope this is understandable. Okay. Now,
Excuse me, ma'am.
yes, ma'am.
There's a color change in some parts of the circuit, right? It is showing green color and it is showing red color.
The color notations are written at the bottom. Now, yellow color is the current flowing, but see the circuit part which is active, that is in blue in color. And suppose your connection is not correct, that is showing in red. So the certain color notations are there, which is written at the bottom of each circuits.
Okay, ma'am. Thank you.
Okay. Now, ma'am, my screen is visible to you. Is it available, ma'am? It is visible?
Yes, ma'am.
Okay.
Yes, visible.
Okay. Now let's move ahead. Okay. So here how we can include in the classroom application. Let's start again. One person at a time. Okay. So how we can address the misconception, how we can apply at the classroom level. So simply a few examples I have shared over here. Like suppose the students think that the current flows from the both positive and negative terminal independent. But this is not Falstad help us to help students to understand how the current flows, how the basic nature of the circuit. To flow the current, the circuit should be closed, complete loop should be required. So it helps to understand what is the basic things required for the flow of current. Now also some students think that more things that the more bulb always makes them like bulb in parallel are dimmer than in series. Okay, there is some misconceptions there. But here with the help of Falstad, student can simulate series versus parallel connection of bulb. They will see bulbs in parallel shine equally bright, while in series the voltage and appear dim. So all the misconceptions will get clear over here. Also, like they think that the current get used up in the circuit. Though current is voltage is used up, not current. As a whole, charge is conserved. We know the conservation of charge is there. Neither charge can be created nor be destroyed. Okay, so voltage, there's a potential, some form of energy is released, not the charge, not the current. Okay, so this misconception also get cleared in this case. The student can observe that current remains the same at all points in the series circuit. They can use current meter to perform the conservation of current. So it is really minutely for a small concept wise if you explain these things. So this will be very beneficial to understand the basic nature of the current. And So, and also there is a one very misconception student face, like a battery supplies a constant current regardless of the circuit. No. Student also believe that battery pushes out a fixed amount of current. No, this is also not correct. By changing the resistance or adding components, student can see how current depends on resistance and Ohm's law. V is directly proportional to current. If I increase or decrease the current with the help of a rheostat or something, the voltage will also change. Okay, so this is the thing which Falstad can fix. Now, this is a Ohm's law ready-made like option. From the option, it is available here. I will directly, this is a register thing. Here we can show to the student, if I open the circuit, here the current will not flow. Only those part the current will flow where the circuit is closed. Okay. Now this is a small assignment for you. Like simple, just draw this kind of a circuit at your home. Do a screen capture of that circuit, and you can share in the WhatsApp group also, and you can share it here also. No problem with that. And this is the second one. You can use as just amperometer, or it is an ammeter only. Ammeter to just see how what is the current flowing at this part, because with the help of oscilloscope or this ammeter voltmeter, you can see what is the voltage over there at that this branch. Okay, so we can make a short circuit with the help of this Falstad, so that we get a hands-on learning in how to create it. I'm giving you 2-3 minutes to do this hands-on exercise. Then meanwhile, I will go to the chat. Screen is not shared. Screen is shared. This is shared. This screen is shared. I hope this is shared.
Yes, ma'am.
Okay, okay. There is a plenty of in other tools. There is a plenty of examples of secondary school level. For secondary school, in this part, we can go to this AC circuit thing. Then we can check LCR, we can check half-wave rectifier, full-wave rectifier. We can explain Kirchhoff's law. These all concepts are available in class 12. For grade 10th, you can go for series and parallel of this cells also, how they behave, how the current behave, what will the equivalent voltage. This part is there. And apart from that, I think this is the only thing which we can explain for 10th and 12th. But for higher classes, for especially engineering cases, we can go for MOSFETs, JFETs are there, clocks are different, timers are there, 555 timers are there, and heavy circuits we can also draw it. And basically, we can do the simulation before creating the circuit. Actually, they can create it in a simulation mode. They can check whether the circuit is operating or not. They can check where the loopholes are there, where are the bad connections are there, which we can remove them easily, because it shows the 2 bad connections, 3 bad connections, and it appears as a red. So we can remove that bad connections, and accordingly we can change, rectify our diagram. Okay, our circuit. So this is the that's why it's make unique. And next go to the another segment. In this Falstad only, you will get a different applets for explaining some physics concepts and mathematical concepts. So I will go directly to that. What you will do? I will share the screen. After that, I will send you to Just give me a second. I will share that web browser. In this, I'm trying to resolve. The screen is visible to you?
Yes, ma'am.
Yes, ma'am.
It's visible.
Okay. Now again we will go to this Falstad. Okay. Now we have explored about the circuit simulator. Okay. Now you will observe over here. This you just go to the Falstad. This kind of window will open. Is it open everywhere? This is a basic Falstad.com window. First of all, you will get this window. Is it visible to you in your mobile or this laptops?
Yes, ma'am. Yes, ma'am. Everything is visible.
Now you
I
go
can
to
see
the
math and physics.
maths and physics. Yes, this is a very interesting. You will enjoy how when we see our like a basic electrostatic potential, magnetic field in 3D mode. So the level of understanding is completely different. Okay. So I will go to the electricity and magnetism. This is for the secondary level. You can see this. I will go to 2D electrostatic applet. This kind of web page is visible. Is it clear? This is coming. Is it visible, everyone? Yes, sir.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. It
Okay,
is
okay.
visible.
Now see, here are plenty of examples. I want to tell students about the single charge. Okay, how they behave. This is a single charge, single positive charge. Now I want to show equipotential. This is a equipotential. This show equipotential. So this equipotential surface are available along with the electric field direction. I want to see for the double charge. I want to see for the dipole charge, positive and negative, how it is there. Okay. So I can increase this equipotential count. Suppose I want to increase its intensity. Suppose they are highly, this charge of very high, then what will happen? I will increase it. See. And you can change the brightness from here. Okay. Suppose you want to see the polarization. Potential in 3D. See, one is positive, one is negative. So this is the structure for, you can zoom in, zoom out. For dipole charges, for single charge, this kind of potential is there at the center. Okay. Now come to the next one. This is the first one. Now you can go to the full screen version is there, full direction, full version, more. You can go to more applets again. I will show you next one. This is also a very interesting one. 2D. See, for the line charge, what is the field magnitude? I will go simple for dipole lines. For the dipole charge, what is the particle speed? Here the particles are there. Number of particles I can increase or decrease. Height scale I can decrease their intensity. Okay. The line separation, suppose I want to keep those separate two charges by certain distance, 1.4 meter. I want to decrease their charges. So see the different level of view they can understand. Now I want to, because we are able to showcase them only flat. We are explaining them on this basis only. This is a positive, negative, how they are behaving. This is a display the particle. See, display particle. This is the particle velocity. This is a particle velocity. None. Okay. Is it interesting or not?
Yes, ma'am. Very interesting.
Come for the dipole, just see for the dipole, how it behaves. Just see for the infinite plane. Okay, just this is a flat plane. Just see the 3D view, infinite plane, how the charge will behave. You can rotate it. You can rotate it. I can just show the rotate for the line. See, you can rotate and see how actually the charge will, what is the potential here. Okay, next come to the another one. Again, the full screen version is available. I will show you this full screen version. Okay, and you go back to the more applets. More you explore, more you will see how the different kind of things are available. This I want to show because it's for grade 10th also, and it is in part of grade 12th also. Its setting generator is there. Now see, north and south pole are there, coil is there. We want to explain them how the magnetic field, you just click on it, how the magnetic field is going to this flux, change in flux. Okay, show the vector area. It is always perpendicular to it. Show the commutator. The commutator is also there. Now I want to tell them how the output is there to generate the output. We will get a AC generator output in the form of ripples. Okay, with stop simulation. And we can rotate the magnet because see, we can actual generators. What happens? It's not like this key. This is rotating. In actual thing, what happens? We rotate the magnets, not the loop. So we can tell them in either way. We can generate electricity, AC current. Either we can rotate the poles and make make loop fixed. Either we can fix the this this magnets and rotate them. In both way, we can generate the electricity. So by visualizing it, student will be easily able to understand all the concept. We can increase or decrease the simulation speed also. What happens if I increase it more DC, more AC current will produce. If I make it slowly, if I rotate it, less amount of AC current. So this I personally love this one. Okay, now I just want to show you another one. This electric motor is there. I see quantum mechanics. This is a little bit higher standard, so student will not able to grasp it. But for see dot product also some this is not this dot product is there. Sometimes student are able to understand this thing part also. So this is a very small tool, dot product tool. I just want to show the actually. Triple tank one. Yes, this I want to show. See, because this is another topic which we are in for grade 12 only, especially in waves, in the both cases, in the sound waves also, in the light waves also. To explain about the interference pattern, we can showcase them. Single source, what happens when the disturbance is there from the single source. In the case of light also, we can explain. In the case of sound also, two source, how the ripples are formed, how the interference pattern is formed. We can, with the help of this applet, we can make them visualize it. In the case of single slit, in the case of double slit, Young's double slit experiment, how exactly happens, how the fringe width is formed. So this is the best way to just see how actually waves are constructively and destructively interference patterns are formed. So this is one thing I want to show. Triple slit, what will happen in the case of triple slit, what will happen in the case of obstacle. So just like a dispersion case, the dispersion case is there, half plane. So, and one more thing, Doppler effect. See, we can showcase them more Doppler. One is source, one is object, and this source is this disturbance is moving from the source to object. So how this what's happening? 3D view stopped. 3D view is a clear wave. We can increase or decrease source frequency. We can increase or decrease damping. So this is very interesting one. I think, and at the same time, here we will see this visual also. Therefore, I've stopped it. Okay, that's right. So what will happen in the case of if I increase the damping, if I change the simulation speed? Okay, so like okay. Now let's move to the next part. So more applets. You can explore more number of applets from here. And as per the your lesson plan, as per your teaching, you can see here ray optics simulation is also there. So we can go for the ray optics also. The eyepiece is there, single ray is there. here we have to, I think, launch some simulator part. So this thing I have not explored. Maybe next time I will explore it and explain you how to use it. So instead of this, next we will go to the next tool, that is algorithm. I hope you enjoyed this one.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes.
It was very nice,
Very
ma'am.
useful, ma'am.
Very useful.
Especially
Yes,
for
ma'am. Very
physics case.
informative.
Especially
Ma'am,
for
can
physics
you,
case. Yes,
ma'am, can you share it in the PPT?
Yes, I will share because everything is there in the PPT itself. Because
After saving, we can give the address or we can paste it in the PPT, no?
Yes. See, suppose this is, I explained the first, as you open it, this is a, like by default, it will come over there. And see here, full screen version is there, direction is there, standalone offline version. This is a very important thing because every time it is like in the schools also, somewhere it is not possible that every time speed is good, we can show such kind of simulation over there. So in that case, we can simply go to the standalone version. And how to download this, I already explained. You can go over there. You can just click on this circuit, one WinZip. Whole zip file will be downloaded in your computer system. Then you will extract that thing. And from the extraction, you will just, after extraction, you can go to the file circuits.js1. And with that file, when you open it, you will simply get that picture. This is a one way. And another way is, which I explained you, just I will go back. Another way is simply file, but I have to this export as a text. Just copy it down in your notepad. Copy it in the notepad. I have copied it in the notepad. Then I will go to the blank circuit. I don't know what is the circuit is there. I will go to the import from the text and paste the text file of the circuit over here and enter. Okay. Oh, this is the previous one. I think I have not copied it properly. This is the previous one, which I have made it. I will just do it again. It's a previous one which I have explained. So I think I have not copied it properly. It has copied the previous one only. Let me explain one thing. New blank circuit, or I will go to the circuits, AC circuit, take the LCR, series resonance. Suppose the circuit is there for file, export as a text. I will copy. Again, it got pasted. File. Either you just copy it, Control C, okay, or you just go to the standalone version for it. Then file, new blank circuit, export as text. You have to remove this first of all, delete, then copy the entire thing which I have copied from there, and then okay. That will come. I will reload. See, it will come. As soon as you reload it, it comes. Okay. So you can do it, and you can do the with the another method also. Simply download the standalone version because that will get opened even in the case of when the net is not functioning. Okay, now come to the another tool, which is a very, very interesting. You will literally enjoy this algorithm part. Okay, so go to the Google. All of you, be with me. Go to the algorithm. Just click on the algorithm. Click on the algorithm. Okay, I have explained you how to. Initially, I told you to simply download it. I hope my screen is visible to everyone.
Yes,
okay.
ma'am, it is.
Okay, so here download is there. There are two versions, free downloads. You just go for the Windows. If you have Mac, you can go over there and you just click on the I agree and download for Windows 10 and or 7 if the old laptops are there, go for Windows 7. Otherwise, I think everywhere we are using Windows 10 only. You just click on it and it will take time to download it. I have already downloaded it. So I will just share you the thing which you will, as soon as you download it, you will get the file and you extract it. Once you extract it, this kind of icon will come over there. I'll go to and add on your desktop. And when you open it, this kind of screen is visible. So if anyone has already downloaded it and extracted, I think they are with this kind of a screen is there. So this is just like a table of creativity, where a platform for creativity, where you can create any number of concepts by your own imagination and explain to the students. Some models are already there, some lesson plans are already there, lessons are there, some tutorials are there, setups are there. So one by one, I will show to you. So this is the files are there, where this is a new file. Here are some storehouse of already inbuilt scenes are available here. Here some are of optics. Basic tools are available here. Okay, so one by one, I will go to the tools. Okay, this is a sketch tool is there, where we can do the sketching part. This a cutting tool is there. So while with the hands-on learning, with the example of, while I will show you how to create any like a concept, like suppose Newton's second law I want to explain. Suppose Newton's third law I want to explain. I want to explain about this mechanics, how the equilibrium of forces are there. Or I want to show you some optics case. I want to show some buoyancy, flotation, anything you think and you can create. Okay. This wall is there, pulley is there. Okay, the spring is there, rope is there, this thruster is there. So one by one, as you use them, you will get a idea of how to what level you can make objects over there. So first of all, I will show you the inbuilt one, so you can get the idea of different tools which you can make with different concepts which you can make it. Okay, suppose simple 3 marbles. Suppose 3 marbles are placed like this. Okay, how the forces are applicable over here, how the different forces are there. You can, for this, what you can do, on the right hand side, you will see 3 blocks are there. You can go to the downward one, visualization, and here you will see this thing. Show names, show values, show component. I will click on component also. I want to see all the total gravity, spring, friction, air buoyancy, everything is ticked. That means they are already is visible over. I want to see velocity also. Since they are not moving, this is a resultant velocity. So everywhere you will see the velocity component is 0, 0, 0, because they are static. Force mg is acting over here. Gravitational force 9.8 Newton is there. Okay, and since on 2 marbles, 1 marble is in a static position, it is balanced condition. So you can see that both the forces, normal forces, are equal and opposite. We can see angular velocity also, they are not moving. So this is a very basic one. Okay, now come to the next one. Suppose this one I want to show you.
Newton's pedal.
This is simple a picture of gas. Okay, at the bottom you will see this, the play button is there. Is it visible to everyone? Let me explain this much.
Yes, ma'am. Yes, ma'am. It is
with the
visible.
cursor, you can go to the zoom part like this. You can zoom in, zoom out. Okay, and then here is left and right is there. This is the apple. This is a thing of gravity. It turns gravity on and off. Okay, so when we draw it, I suppose I will just make its strength 0. In this case, if I play it, okay, because it is an inbuilt one, here I cannot change it. I think it is an inbuilt one. But when I draw it by myself, so in that case, we can change here also. Okay, now here it is hot terminal is there, here cold is there. In that case, what will happen? In that case, what will happen? In the hot case, we can see in the hot case, it is moving vigorously, and in the cold side, we see the air molecules are more compact, more dense. Okay, so here the simulation speed is very slow. I can increase the simulation speed also. Come to the next, because I have changed that thing. Come to the next one. Suppose it's a pulley path. Okay, here we can see this plate. I can increase or decrease the simulation speed from here. See, if the gravity is not there, what will happen? They will float like this. Now I just on the gravity. So after balancing, now I want to see the forces. What are the forces acting on it? Different forces, center of mass, how they are aligned over there, how they are, we can see it over here. I want to see the velocities also. So this is the velocity part. I want to see the angular velocity. So angular velocity. I want to see the values. What are the values on each, acting on each mass particle, mass object.
If
So
we want to increase the weight,
we can increase it
mass.
because it is an inbuilt one, ma'am. Here we cannot change. This is an inbuilt one. When I create by myself, so in that case, you can choose that mass, momentum, show component. So suppose show name, you can just click on the things and you can visualize that parameter.
Ma'am, can you add acceleration and tension?
Acceleration and tension. Tension is already there. This is the tension only. I think
tension on the wire.
Tension on the wire. I think it is not visible. No. Friction is tension only, torque, T. So here torque and tension both are given over here. See, whatever components which are mentioned over here, like attraction, axle, normal, air friction, chain, thruster, controller, all are, we can visualize over. For forces case. For the velocity, again, view velocity, we can see their velocity also. We can see their component also. We can see their angles also in the case of velocity. For the momentum, we can see their momentum also. We can view angular momentum also. So these are the only things which are available. Okay? I will just draw one thing, and I hope that will make you more clear picture. This is the inbuilt one. I am coming to the new scene, which I make it my own. You can choose any of the background from here. That's default, autumn, black, any background of your choice. You can choose it. I've chosen this one. This is a platform is there. So first, suppose you want to hang it, and this is a plane. This is a plane. For you have to choose this plane. This is a like roof is there. You can make it inclined plane also. You can make vertical plane also. You can make it roof also. So just for an easy picturization, I will make a simple this inclined plane. Okay, I will make an inclined plane. Now I want to just show the concept of buoyancy. For that, I will just take this tool brush size. This is a brush. You can choose this brush like calligraphy is there, merge is there, auto glue is there, brush is there. This is a brush. I can increase or decrease the size of the brush. I can take this size. Suppose this I want to make one container. Okay, I want to make one container. Then I fill it with box. I will fill it with box. What is this? This I want to fill it with water. So how can I show this water? I will just click on the right click. Here you will see erase, liquefy, spongify, clone, mirror, show plot, selection. Different options are available. So first I liquefy it. So it converted into liquid. Okay. Then I want to showcase this thing. First of all, you have to stop the simulation. Here, when we are creating any new concept, you will not on that simulation thing. You just create it, and gravity should be off. Gravity should be off, otherwise everything will fall down. I will make 4 or 4 balls, okay, of different sphere. This is the material, right? Glass. For this, I take one glass. I made one of glass. Second, I made of gold. Next, I make of helium. Next, I make of ice. This I make with the wood. Okay. So all these 4 I have taken. Now I can increase or decrease the density from here also. Now, once I have created this, what I will do, I will just press on this turn gravity on. Turns gravity on. You will see the ball which I made up of helium, it flows upside because its density is very much low. So it is not here. The gold has a very high density, it falls down. This is I have made up of ice, so it is in between, and this is made up of wood. So I can increase its density from here. See, I've decreased the density of wood, it floats on the top of the water. I increase its density greater than the water, 1.8. Okay, normally it is 1 for water. So you can see this, you can increase or decrease. We can change their density from here also. We can make it with the steam also. We can make it for the stone also. So how the flotation happens, what is the concept of behind flotation, this we easily able to understand. Now, what will happen to show the concept of gravity? This will be very important. What will happen if the gravity is not there? What will happen? All the air molecules, water, everything will float in space. Now, what will happen if the gravity is coming back? Okay. So this is a very interesting thing which I.
Do we have to download this algorithm?
Yes, ma'am. This you have to download it just like from the Play Store. You download any other app in the similar way. You just download it. Okay. Now this is the one thing. Now I want to show some new thing from any new thing.
Is web version available for this app?
Sorry, sir.
Web version available for this app?
Web version,
like
yes.
Applet?
Like Applet. No, it is not Applet, sir. It is a proper free software, free tool by which you can make any kind of with your creativity, you can make any kind of concepts. This is different because that is a ready-made one. That one is ready-made one, Java applet. That programming is written in the Java format, and then they are in the applet, Java applet, and they are. So here we are creating ourselves. It is a platform where we can create.
So this is not available on the web, right? This is software only.
It is. You have to download, sir. You have to download this tool, Algodo tool.
Right.
You have to download it, and this is just like a whiteboard. It is there. So only I think 5 minutes are remaining. I will quickly go to the very interesting one, and then see here. You will suppose which is already available here. You can just go through this, which is available over here. I will come to one part. This one. This algo box. Okay, when you explore this algo box, here the plenty of lesson plans are already, like some games are already formed. Okay, which you can play over there. Okay, this is another thing which I want to showcase you. That is a lesson plan. That is a lesson already inbuilt lesson plan out there. Come to this lesson plan. Now, I will take a browse lessons. You can explore yourself about the quick tour about how to use the Algodo lesson. I will just showcase one of the pre-made lessons for your activity in the classroom. So see, already in motion, construction, friction, all the topics are available here. Free fall. Suppose I will take one of the free fall. See. So already you will see target key stage here. All the lesson plan is written over here. Steps in Algodo is here. I just want to say this thing.
Uma ma'am, 5 minutes only left. So I request you to wind up the session in 5 minutes.
Right. Okay, ma'am. Sure, ma'am. Sure. Okay, I will just tell them this one, this simple one. I just make it this, make it this tool. Okay, and then now with the help of this and with the help of this thruster, they can apply, they can push it. Okay, I can push it, and I will explain them until and unless you apply the force, the object will comes in the remain in the that position only, given position only. Then this you can see this. because I have applied the force, continuous force. So it will rotate until and unless, because I have applied the force over here. Circular motion part. Then in this circular motion part, I can see all these forces. What are the forces they are acting over there? What are the velocities? Angular velocity. Now I will play it. Let me reduce the simulation speed. It is visible right now. I'm not able to see it. But that simulation speed, you can decrease it and we can easily see this. Achha, one more thing. Suppose for the inclined plane, new scene, I will choose this scene. For the inclined plane, go to the inclined plane. With this tool, you can make any kind of object like this. Any kind of, suppose I want to draw one man. Suppose one man, I want to show them. Man was standing over here. Okay, then I will just hang it with some, take them some pulley, hang it with some rope, then play. Means just, it is an idea. We can make any kind of shape with them. And if that, okay, because gravity is on, so whatever I'm drawing, it will fall down. For that, I have to make it small, or this. One very interesting thing, I will just let you know this thing. I will make one this thing.
For drawing, we can use pen tab, ma'am.
This ball is there. I want to show them how it bounces, or about the friction. I want to study, tell them how it's about the static friction, about the kinetic friction. So we can create it. We can create a problems of free body mass over here. Mechanics part, we can create it. We can go for the oscillation part, we can create it. For optics, we can create from here. This lens, we can make it. Then from this laser ray, I will make it this laser ray, and I can show them how the light will behave in the case of, we can increase its size. Okay. And different, we can use this prism also. I can make a one prism also. What we have in the case of prism, or if I place it here, how the light will changes its direction. So these are the different things which you can explore. More you can explore, very, very uniquely, we can explain it over there. Any questions you want to ask, because I have to wind it up. Any questions?
मैम ये लैपटॉप पे यूज हो सकती है क्या लैब जो भी आपने
Of course, yes,
it is available
yes, it is available in laptop, it is available even in Android, maybe not in Android, it is in Windows only. These are already pre-made one sessions.